Hi students, I welcome you all for the sessions. Today we'll be going to start a new chapter, that is chapter number 4. That is complex numbers and quadratic equations. The name of the chapter is quadratic equations and complex numbers. We'll be going to discuss about detailing about this topic. Before that, what is the meaning of quadratic equations? Quadratic equation generally you have been studied in your high school level. Quadratic means which contains x square term, right, which contains x square term, x term and one constant term. So generally we'll be writing a quadratic equation in the form of ax square plus bx plus c is equal to 0. Okay, this will be called as a quadratic equation. This is a general representation of quadratic equations, and I am writing here. So the equations contains x square term, right, x square term and x term, and one is constant term, that will be called as quadratic equation. Generally I am writing here equations x square plus 1 is equal to 0. This is an example of quadratic equations. So here in this example, a is equal to 1 and b is 0 and c value is 1, right? So b is 0 here, so bx naught is there, c value is 1 here. So when we are solving this x square plus 1 is equal to 0, then x square is equal to minus 1 and x is equal to square, I am taking this side, plus or minus of root minus 1, and this value of I is equal to root minus 1. This one we are taking as imaginary value. So imaginary value is I is equal to root of minus 1, then x solution is plus I and minus I. Okay, plus I and minus I are the solution of this equations, and if we take I is equal to root of minus 1, then what is the value of I square? So I square is minus 1. Okay, so here taking on both side, root minus 1 square I'm taking, and this square root and root is cancelled, and value of I square is minus 1. And now we can able to write what is the value of I cube. I cube we can write as a I square into I. Right, I square value is minus 1. We know minus 1 into I is minus I. Like that we can write for other further values, I4, I5, I to the power of 6, I to the power of 7, all those things we can able to write. Now we'll be come to the complex numbers. Complex numbers, how we are representing. So complex numbers generally we are representing in the form of, so z. Okay, z is the complex number here, small z. So a plus ib. Okay, this is the example of a complex number. Complex number contains a real part. The first part is a real part. So okay, this is real part, and the second part is called as imaginary part. So that contains I here, imaginary value. Okay, imaginary part. Okay, imaginary part, and real part of z. So real part of z means I will write here rez. So real part of z, and im of z is means imaginary part of z. Real part of z is a, and imaginary part of z is b. Imaginary part of z is b. Okay, the other form of equations I will write examples of the complex numbers. I will write here 2 plus I3. This is an example of complex numbers. I will write minus 1 plus I root 3. This is an also example of complex number, and 4 plus I minus 1 divided by 11. These are examples of complex numbers. Now I am taking the two complex numbers are said to be equal. Okay, I am writing two complex number. Z1 is equal to a plus ib, and Z2 is equal to c plus id. Okay, these are two complex numbers. When I said to these two complex numbers are equal, only when a is equal to c. So the real part of both are equal and imaginary part are equal. Okay, so when two complex numbers are said to be equal, when a is equal to c and b is equal to d. Okay, real part are equal and imaginary part are equal. Now we come to the, we can take an examples. By taking an example, we finding the value of x and y here. Okay, we are finding the value of x and y. So if x 4 into x, right, 4x plus I 3x minus y is equal to 3 plus I into minus 6. Okay, So then we need to find here value of x and y. How we can find? So here these two are complex numbers are given in equal form. Okay, equal form means the real part are equal and the imaginary part are equal. So this is imaginary part. I can write for real part 4x is equal to 3 and imaginary part is r equal to 3x minus y minus 6. These are this is the imaginary part, and the x value will be get here. X is equal to 3 by 4. This value I will put here in this 3 into 3 by 4 minus y minus 6. Okay, this 9 by 4 and y minus y I am taking this side. It will be positive y, and here minus 6 I will take this side. Then it will become plus 6. So 4 is LCM here, 9. 6 4 is 24, 24 y. So y is equal to 24 plus 9 is 33 divided by 4. So these are the solution of x and y of the complex numbers when two complex numbers are equal. Okay, so now come to the algebra of complex numbers. Okay, now come to the next topic is algebra of complex numbers. So what is the meaning of this? This meaning is that so addition of two complex numbers, subtraction of two complex numbers, and multiplication of two complex numbers. So all those will be going to study. The first one is that addition of addition of two complex numbers. Okay, the first title is that addition of two complex numbers. So two complex numbers, that means z1 is equal to a plus ib and z2 is equal to c plus id. These are the two complex numbers. Okay, so when we are adding these two complex numbers, will be the resulting new complex number is also in the form of a complex number. Okay, I am adding this a plus ib, okay, plus c plus id. Okay, so now if we are this real part I'm writing one side a plus c, and imaginary part I'm writing another side, that is b plus d. So okay, this is the new form of a complex numbers, and it is also in the form of a plus ib. It is in the also in the form of a plus ib, right? This is in the also form of a complex number. Okay, now so here we'll be seeing the some laws. So here in this under this addition of two complex numbers, we'll be finding closure law. What is the closure law is here? So when closure law means when we are adding two complex numbers, the resulting new expressions, the resulting new complex number, it is in the form of a the resulting new expression, the resulting new expression, it is in the form of a plus ib. Okay, so when we are adding two complex number, the resulting expression, it is in the form of a plus ib. It is in complex number, right? So that is the meaning of closure law. And the second one here will be under this additions of two complex numbers. So the second law is that commutative laws, right? Commutative law. So what is the meaning of commutative law? So when we are adding z plus z2, this is equal to z2 and plus z1. So the same, right? When we are adding complex number z1 plus z2, that is equal to z2 plus z1. That is, this one will be called as a commutative law. And third one here will be seeing the associative law, right? So these you have been studied in sets. Okay, in the same way here also we are defining these laws. So associative laws, when we are adding three complex numbers z1 and z2, I am adding with the third one complex number. So this is equal to z1 of second addition of two complex numbers. Okay, this is called associative law. And now, so when we are adding a okay, when we are adding a, so fourth one, when adding a complex number with a 0, then it will be z only. And when we are adding a z with the inverse means what? Negative, right? Negative z. So inverse of z is 1 by z. Also we can write, or also we can write as minus z. Okay, minus z is minus z equal minus z, and 1 by z is both are same. When adding z with the inverse of z, so will be 0. Will be having the value is 0. Now we'll be going to discuss on difference of two complex numbers. So I will write here Cn means complex numbers. You just remember that. Okay, so this difference means subtraction. So when we are having two complex numbers z1 minus z2, so this one we have to write in the form of z1 plus, so this minus z2 I'm writing in the bracket because we need to write a plus b, a plus ib. So this in this form we need to express a complex number, right? So I will take example here. So 6 plus 3i, so this is z1. Okay, this is z1 minus of z2. I'm writing the 2 minus I. So this one we need to express in the form of z1 plus of minus z2. We need to express in the form of 6 plus 3i. So plus I will write here. So this minus I will take inside and plus I will write here. So therefore it will be minus 2 plus I. Okay. So now we, if we further solve this one, so this 6 minus 2 is 4, and 3i plus I is 4i. So it is in the form of a plus ib, right? So plus is here. So this is the difference of two complex numbers. Usually we are expressing in this taking the minus inside the bracket. Okay. So next we will be going to discuss on multiplication of complex numbers, right? We will be going to discuss on multiplication of two complex numbers, right? Two complex numbers c and I am writing here. So means what, here I am writing z1 into z2. Suppose we take z1 is equal to a plus ib, and z2 is as c plus id. Okay, when we are multiplying this z1 into z2 means here a plus ib into c plus id. Okay, when we are multiplying this one, the first term I am multiplying with this first one and second one. Okay, this a plus a into c and a id. Right, the second one I am writing with the second one with the first and second one with the second. Right, so this will be ibc and I square bd. Right, so this AC and the I square value we know, right? I square is minus 1. So it is minus BD. So minus BD I'm writing it this side. Okay, minus BD will writing this side. And I will take common here. So imaginary part, that is AD plus BC, right? So this one I am writing in the form of A plus IB, right? This is the complex number. So usually we are expressing the complex numbers in the multiplications. Sorry. So here also we will be going to discuss some properties. So one is that closure law. So closure law means what? When we are multiplying z1 into z2, so the new form of expressions here, it will be in the form of a plus ib, right? It is in the complex number, that is will be called as closure law. And the second one is that commutative laws. So commutative law usually z1 into z2, so that is equal to z2 z1 z2 z1. So this is commutative law, both values are same. And associative laws is when we are multiplying z1 into z2, so okay, then product with the multiplication of z3, this is equal to z1 z2 z3, right? So these both are equal, so this is called associative law. And when we are multiplying this z into z inverse, z inverse is z to the power of minus 1, that will be, usually we will be writing z inverse is as a 1 by z, so z will be get cancelled, will be having 1. Okay, this is multiplication of complex numbers. Now next we'll be going to discuss on division of complex numbers. The fourth point is the division of, so division of complex number Cn. So division, you know, right? So z1 divided by z2. So here z2 condition is that z2 is not equal to 0. Means what? When z2 is equal to 0, then it will be 1 by 0. 1 by 0 is does not satisfy the condition. So it lies as a infinity. It lies as a infinity. So the condition for division of complex number is z1 by z2. So z2 is not equal to 0, and this one we are expressing as a z1, so into 1 by z2. Usually we are writing z1 into 1 by z2. We are simplifying this one with the by taking the example. So suppose I am taking example z1 as a 6 plus 3i and z2 as 2 minus I. Okay, so when when we are expressing this one in a division form, z1 by z2, so z1 is 6 plus 3i. Okay, 6 plus 3i, and z2 I am writing as a separate 1 by 2 minus I in this form, right? I am writing this in these forms. Okay, so z1 into 1 by z2. Okay, so z1 by z2 I am writing z1 into 1 by z2. So this 1 by z2, so this one we are simplifying with the with the multiplication of 2 minus I we are having. I am taking 2 plus I here and 2 plus I here. Okay, both side I'm multiplying the denominator and denominator by 2 plus I. So when we are simplifying this one, we'll be having 6 plus 3i. Okay, 6 plus 3i. Finally, we the main aim of this division z1 divided by z2, we need to express in the form of a plus ib. The final expressions in the form of a plus ib. Okay, so now this 6 plus 3i I am taking outside. So and now here 2 plus I is there, so 2 plus I will write here. So this 2 minus LCM is what? 2 minus I and 2 plus I. So 2, it will be a square minus b square, right? So what is the, so LCM is here 2i into 2 plus I. So it is in the form of a square plus a minus b into a plus b is what? A square minus b square. So means what here? LCM is, so LCM is, so 2 square 2 square 2 square, so 2 square minus b square is there. I will take plus here, then it will be minus 1 square, right? So and so minus 1, minus of 1, this I will take here. Okay, minus of minus 1, and here LCM is same, uh, 2 square 2 square plus minus 1 whole square, right? So I am writing this one. So again simplifying this one to 6 plus 3i. So this will be, so LCM is same here, so 2 plus I here, 2 plus I. Okay, 2 plus I, and this 2 4 plus LCM is same, 4 plus 1 is 5. So it will be 6 plus 6 plus 3i, 1 by 5 I will take common, 6 plus 3i into 2 plus I, right? So the here 1 by 5 is I'm taking outside 1 by 5. So multiplying this 6 into 2 is 12, and 6 into 2 is 12. 3 into I is 3i square, so 3i square, and 6 into 2 is 12, and 6 into I is 6i. Okay, I will write here 6i, so it will be 6i, and then second term, with the second term I am taking, so it is a 6i and 3i square, right? 3i square is minus 1, therefore it will be minus 3. 12 minus 3 is 9. Okay, it is 9, and 6 plus 6i is 12i. This is the final expressions will be for the final expression in the form of a plus ib, right? Now we'll be discussing on power of I. Okay, what is the power of I? So power of I usually, so I value is the root of minus 1, and when we are I square is what? So I square is minus 1. What is the value of I cube? So I cube we are expressing, this one is I square into I. So I square value is minus 1. Minus 1 into I is minus I, right? So now what is the value of I to the power 4? So I to the power 4 we are expressing I square of square. So I square value is minus 1. Minus 1 square is what? 1, right? So what is the power of I5? So I5 I am expressing, this one is I square into I square, I square of square, it is I raised to 4 and into I. So I raised to 4 value is, we know this one is 1. 1 into I is I. Okay, so I cube value I am expressing, this one is I square to the power of cube, right? I square is minus 1. Minus 1 whole cube is minus 1 value. So this is the power of I. So what is the different values of I? So we are expressing in the form of I. Okay. Now will be this formula we know, right? Uh, what is the formula for a plus b whole square? So a plus z1 complex numbers also we can take a plus b whole square is a square plus b square plus 2ab, right? That is 2z1 z2. It's like this, a minus b whole square, a plus b whole square, a plus b whole square. So the formula, same formula we need to follow in the complex numbers also. Okay. Now we will take some examples, and by solving some expressing the complex numbers in the form of a plus ib, right? So the example I am taking here. So first one is that minus 5i into 1 by 8i, right? So this one we need to express in the form of a plus ib, right? A plus ib. So how we can express this one? So we need to express this one in the form of a plus ib. So we need to multiply here. So here I into I is I square. So it is 5 I square by 8, right? 5 I square by 8. Then it is I square is what? I square is value is minus 1 by 8. It is 5 by 8, right? It is 5 by 8. So minus into minus is plus 5 by 8, and I is 0 here. I is 0, right? Right. This is I is 0. We can write in this form. The second example I am taking here, so which is minus I into 2i, so minus 1 by 8 I cube, right? We need to simplify this one. So here minus I is there, so minus I will write minus I into 2i is 2i, so 2i square. And what about here? So here minus, the minus is there, so minus of cube is minus only. Okay, minus I cube, right? Minus I cube, and 8 is there. 8 3 times I will write here 8. So this minus into minus is plus, so it is 2i raised to 5. 2i raised to 5 divided by 8 into 8 into 8, right? So 2 ones are 2 fours are. Then I raised to 5 value is what? I raised to 5 value is, we can write I square into square of I divided by 4 into 8 into 8. So I square value is minus 1, minus 1 square is 1, that is I. 1 into I is I square value is minus 1, minus 1 whole square is 1. 1 into I is I here. So 4 into 8 into 8 is a 256, right? 256. So the final expression is, so we can write this one is 1 by 256, 1 by 256 of I, right? So first real part is 0 here, real part is 0. And we'll take another example. So here we need to express 5 minus 3 I into whole cube in the form of a plus ib. So this is the formula of a minus b whole cube. So a minus b whole cube formula we know, that is a cube plus b cube plus 3ab into a minus b. Sorry, the formula for a minus b whole cube is a cube minus b cube minus 3ab into a minus b. This is the formula, right? So a cube minus b cube minus 3a square b and minus 3ab square, right? We need to write in this form. So here 5 minus 3i whole cube, I am writing this a cube is what? 5 cube. So minus is minus b cube is 3i, so 3i whole cube minus 3 into a is 5, so 5 square, b is 3i, and minus 3 into a is 5 and b is 3i, this is 3i square. Okay, here a value is 5, a value is 5 and b value is 3i, right? B value is 3i. So 5 cube is 125. So this is 3 into cube is what? 27. 27, and I cube is so I cube is, what is the value of I cube? I cube is I square into I square is minus 1 into I is, it is minus I. Minus I means it is minus I, and here 3 nines are 25. 25. So we'll be having 25 into 3 into 3. 25 into 3 into 3 is 135 here. So 135. So it is 135i, and here we'll be having 225. So this is 25 into 3. 25 into 3, 3 5 is 15. 3 2 is 6 is 75. 75 into 3 is 3 5 are 15. 3 225. So it is 225. Sorry, it is 225. 225i. So, and what about this? So it will be 3 into 5 is 15. So 15 into here 9, 9 I square is minus 1 here. So it is minus 1. So then we'll be having 125. So minus into minus is plus, plus 27i, 225i, and here minus into minus is plus. 15 into 9 is 15 into 9 is 15 into 9 is 135. So it is 135. So and so now 125, 125 and 225, this is 125 is here, 25, 225 minus 27 5 is what? So 198. This is 1 minus 198. So minus 198 I. So it is uh, this is minus 125. I square is minus 1 minus uh, sorry, here minus into minus is it is plus 3ab square, right? It is plus 3ab square. So it is plus means it plus plus into minus is minus, where then it is minus 10. Sorry, it is minus 10. So it is minus 10. The final expression is minus 10 in minus 10 minus 10 minus 198 98i, right? Now will be come to the next topic, that is modulus and conjugate of complex number, right? Modulus and conjugate of complex number. So here modulus means what? Z is a complex number. So this mean when we are writing in a when we are Z is we are writing in a like this bracket, right? Like this bracket. So our a line in between lines we are writing, this is a will be called as modulus. So what is the meaning of this? So modulus is when we are Z is right, Z is a plus ib. When we are writing modulus of Z, so value is square root of a square plus b square. So that is the meaning of this. And conjugate is means what? So I am writing Z is equal to a plus ib, and conjugate will be represented over a bar, right? Z bar, that is the plus will be converted into minus, a minus b. So that will be called as a conjugate. So now we'll take so 3 plus I example. When we are expressing this one in modulus, it is square root of 3 square 3 square plus 1 square. Right, here 1 will be there. I is means I into 1. So it is in the square root of 10. Okay, when I am writing 2 minus 5i a modulus, so that is 2 square plus 5 square. 2 square, 2 square, so 2 square, so it is 2 square. So here b is minus 5. It is minus 5i square. So it is 5 square is 25, 25 into 29, square root of 29. Right. So conjugate number will be writing. So here 3 plus I. So conjugate number is what? 3 minus I. And 2 minus yi. What is the conjugate of this number is? So it will be convert plus here. 2 plus 5i. Understood. Now we'll be finding the value of inverse of number. Okay. So inverse of number. So z inverse. So z inverse is what? 1 by z. So 1 by z is what? A plus ib. Okay, this one we are expressing this a plus ib is there. I am expressing here a minus ib into both side denominator and denominator. I am writing a minus ib and a minus ib. So it will be in the form of a minus a. So here a plus is there. So plus I will take a minus of b, and here it is I am writing a square plus b square. Okay, a square plus b square. So this is a plus ib is what? Is a z inverse, and it is a it is a so it is a modulus of a square. So therefore we can write the expression for z inverse is what? So it is a conjugate and modulus of combination of conjugate and modulus. This is a formula, right? This is a formula. So now we can able to, based on this, we can able to find the value of uh, inverse of number. Example, I will give an example to find the 2 minus 3i. We need to find here multiplicative. So multiplicative of inverse of number. So we need to find inverse of number. So z inverse we need to find. Z inverse is what? So z conjugate z and modulus of a square. So means what here? Z. So z is here given 2 minus 3i. So and modulus of z will be writing 2 square plus minus 3 square. That is 2 square is 4, 4 plus 9 is 13, root 13. And now when we are z square is we are writing, then it will be 13. It will be 13, and z bar is what? 2 plus 3i. Now if we write here 2 plus 3i, and z square is 13 here. So 2 plus this we can write 2 by 13 I 3 by 13, right? 3 by 13. So this is we are writing the inverse of the functions. Now we'll take another example. We need to express in the form of a plus ib. Okay, so we need to express in the form of a plus ib. 5 plus root of 2i and 1 minus root 2i. So here I at the outside. So when we are writing this one, so how we have to take? So 5 plus root 2i and 1 minus root 2 into I. This one I am taking here 1 plus root of 2i and 1 plus root of 2i. Okay, with reference of the denominator we need to write here conjugate number, so that is 1 plus root of 2i and 1 plus 2 root of 2i. Both side I am writing, so the both this term and this term, both term are same. So when we are writing this one, so here we need to multiply this one. So it is 5, right? 5 into 1 is 5, and 5 into root 2i is 5 root 2i, and root 2i, and root 2 into root 2. So here root 2 into root 2 is 2 I square is there. Root 2 into root 2 is 2 I square, and this will be a plus b whole square. A minus b into a plus b is a square. Sorry, it is a square minus b square. B is root 2 into I square. So this I square is value is minus 1. I square value is minus 1, and therefore I am writing 5 plus 5 plus 5 root I, 5 root I, and plus root 2 into I, and this is minus 2, and we'll be having here 1 minus. So here root 2 square is what? Root 2 square is 2, I square is minus 1, it will be 1 plus 2, right? It is 1 plus 2, and when we are simplifying this one, we'll be having 3. 5 minus 2 is 3. Okay, 3 plus here root 2i is there, means what? 5 plus 1 is 6 root 2i, 6 root 2i divided by 3. So this I am taking 3 as a common here. So when we are taking 3 as a common, then it is 1 plus 2 root 2i divided by 3. 3 will be get cancelled, and final expressions will be having 1 plus 2 root 2i. Okay, this is the final expressions. And the second example I am writing here, I to the power of minus 35. This one we need to express in the form of a plus ib. So this is a I to the power of minus 1 I to the power of minus 35. This one I am writing 1 by I to the power of 35, and 1, this I to the power of 35 I am writing I square of 17. I to the I square of 17 is 34. 34 into I is what? 35. Now 1 divided by I square is minus 1. Minus 1 to the power of 17 into I. So this will be 1 divided by, it is minus 1. Minus 1 into I is minus I. So this I am multiplying on both sides, I into I. Therefore it will be I divided by I square. So I square, then therefore it will be, final solution is I we are having. I square is minus 1 into n plus 1. So I is the 0 plus I is the solution for this question. Okay. In next class we'll be solving the exercise problem 4.1, and thank you for watching the video. Please subscribe the channels, hit the bell icon for notifications. Please do share with your friends. Thank you.